Welcome back. Today we're going to cover 2.4, so solving quadratics algebraically. It's going to be split over two parts because there are a lot of methods to solve quadratic equations algebraically. The two that we're going to go over today are finding square roots and completing the square. Tomorrow we'll cover quadratic formula, so please be ready for that. Right? So go and write down the essential question: how do I solve quadratic equations with real coefficients that have complex solutions? So I'm going to go over 4 examples today, 2 of which will have real answers with real numbers only, and 2 of which are going to be complex numbers that incorporate imaginary numbers. Okay? So the first one that we want to focus on is finding square roots. So in terms of finding square roots, really all you're doing is just taking the square root of both sides. So sometimes quadratics are written in the form like this: x minus 6 squared equals negative 81. Actually, just kidding. That's example 2. So start off with this one: x plus 4 squared equals 8. Okay. So in this example, we have a binomial squared, and if I were actually to expand it out, it would be a complete quadratic equation. However, when we factor it down, it can be written in this form. In this case, all I'm actually going to do is take the square root of both sides. So the square root of x plus 4 squared is the square root of 8. Now one thing you have to remember is that if you take the square root by yourself, like actually manually take the square root like this, you end up with 2 answers, positive and negative. The nice thing here is that the square root and the square root just cancel each other out. So we get x plus 4 equals plus or minus the square root of 8. Okay. We do need to simplify this to simplest radical form, and we're also going to subtract 4 to both sides. So here we get x equals negative 4 plus or minus, and as you should know by now, the square root of 8 is simplified to 2 radical 2. Okay, so this would be our 2 answers. If you want to expand them out, you can rewrite it as negative 4 plus 2 radical 2 and negative 4 minus 2 radical 2. Okay. So that's example 1. We ended up with real numbers, not exactly the nicest ones, but they are still real numbers. In example 2, we're going to do the same thing. However, we are going to end up with complex numbers. Okay, so this one is actually going to be the one I wrote earlier: x minus 6 squared equals negative 81. Right off the bat, you can tell that we will end up with imaginary numbers, because if I take the square root of a negative number, it's going to be imaginary. Previously, we would have told you to write no solution because of that negative, but because we are now working with imaginary numbers, we want to include those. Okay, so I'm going to take the square root of both sides there. I end up with x minus 6 equals the square root of negative 81. It's also plus or minus. Okay. So at this point, you want to go ahead and simplify this one, but you also want to make sure that you add that 6 to both sides. So here I'm going to get x equals 2 different answers. I have plus or minus, so 6 plus or minus square root of negative 81. We know that by taking the square root of a negative number, we'll end up having an I, and thankfully the square root of 81 is just 9. Okay, so our answer is 6 plus or minus 9i, but we do want to write it in standard form for each one of them. So the first one is 6 plus 9i, and the other one is 6 minus 9i. So these are our 2 complex number solutions in standard form for this one. Okay, so these are the x values that satisfy this quadratic equation. Alright, so that's it for finding square roots. We're going to go ahead and jump forward into completing the square, something that a lot of you guys might have forgotten, but was pretty important in Algebra 1. Okay, so let's go ahead and start this off. By recalling that a quadratic equation is something in the form of ax squared is x squared plus dx plus c. So whatever number is in front of x squared will be our a, the coefficient in front of x will be a b, and the constant that stands by itself will be c. Okay? For completing the square, you might want to reference your textbook on completing the square. There will be steps in there. I'll go over them briefly in here. Completing the square, sorry. Okay. So in terms of completing the square, our goal is actually to get numbers that we'll be able to factor out a lot simpler. Because by looking at this one, I know that I won't be able to get something that looks like, I'll put it right here, it's minus a squared. It's not a perfect square. It's not going to work out, or we get one of our special products. So because of that, I actually want to get rid of this 2 and move it to the other side. So I'm going to move the 2 over. I end up with x squared plus 6x equals to negative 2. Now what I need to do here is actually add a number to both sides that will help me complete the square. In other words, allow me to get some factor that's in the form of this guy, so that by the end I'll just have to take the square root of both sides. To do that, I have to use this little formula, b over 2 squared. This thing is going to have to go into both of my empty circles right here. And in this case, b is equal to 6. Okay? So there's 6 right there. Knowing this, let's go ahead and do that. So b over 2 squared is going to be 6 over 2 squared. That's 3 squared. 3 squared is 9. I'm going to add 9 to both sides of my equation here. So x squared plus 6x plus 9 equals negative 2 plus 9. With this, we're going to go ahead and simplify on the right side as well as factor on the right side. With this, I end up getting one of my special factoring terms, and this breaks up into x plus 3 squared. Okay. If you need to remember how to factor, try to review that on your own. So x plus 3 squared is going to equal to positive 7. We take the square root of both sides now, just like before. I end up with x plus 3 equals plus or minus 7. Radical 7, I'm sorry. Subtract the root of both sides, and I get x equals negative 3 plus or minus radical 7. If you want to square it up, negative 3 plus radical 7, negative 3 minus radical 7. Alright? So there is a real number example where we're completing square, and now what else do I expect you guys to do with imaginary numbers? Okay. And I'm sorry, that was actually example 3. So we're going to go ahead and move on to example 4, finish this up. So example 4, moving on. Example 4, I'm also going to ask you guys to solve by completing the square. Now some of you might realize, hey, I can actually use a different method and still get that same answer. That's true, but we are going to be asking you guys to show your ability to solve in different ways. Okay, so for these, you do need to complete the square. Alright, so here comes the final example. I'm going to have x squared minus 4x plus 13 equals 0. So obviously this does not result in a nice, simple square factor. So I'm going to subtract 13 on both sides. I get x squared minus 4x equals negative 13. My b in this case was negative 4, so b over 2 is going to be negative 4 over 2 squared. That's negative 2 squared, which is 4. So I'm going to be adding 4 to both sides. So x squared minus 4x plus 4 equals negative 13 plus 4 as well. Here, I'm going to go ahead and factor out some special products since I completed the square. X minus 2 squared equals negative 13 plus 4 is going to be negative 9. So once more, take the square root, I get x minus 2 equals plus or minus square root of negative 9. By now we know it's 3i. add the 2 to both sides. Let's finish it up first. X equals positive 2 plus or minus 3i. Split it up so we have standard form 2 plus 3i and 2 minus 3i. Alright, so that is taking the square root, completing the square, 4 different examples. If you need to, go ahead, replay, and check as needed. Alright, so go ahead and move on to the Google Forms now. Have a good day, you guys.